This is the electrolysis question from November 2017, paper 2. It says the simplified diagram below represents an electrochemical cell used in the refining of copper. One of the electrodes consists of impure copper. So when we refine copper, we go from impure copper to, look at my handwriting, impure copper goes to pure copper. Okay, and how do we do this? We take copper and we turn it into copper 2 plus ions, and then on the other side of the cell we take copper 2 plus ions and turn them back to copper, and any impurities get lost along the way while we are doing this these two reactions. So it's exactly the same reaction, but it is on the one side of the cell is the copper going into solution, and on the other side of the cell is the copper going into copper metal. So we have to be doing this with a DC power source, a direct current power source, because otherwise the anode and the cathode will keep switching and you will not get any net overall effect on one electrode. So now it says to you, when the electric current passes through the copper chloride, the mass of electrode P increases. That means this one here is getting bigger. What is happening here? At this electrode, copper is formed. That's the only way we can increase our mass. If we go from copper 2 plus and we gain 2 electrons and we turn into copper metal, it will make the electrode get heavier. And this is exactly what we want to do. This is the pure copper that is now forming there. So it says to you, is electrode P the cathode or the anode? And then it says, write down the relevant half reaction to support the answer. Well, here's the relevant half reaction. And then look at this reaction. Is this a reduction reaction or an oxidation reaction? Remember, oil rig, red cat. Oxidation is the loss of electrons. Reduction is the gain of electrons. So here we are adding electrons. This is a reduction reaction. And if we go oil rig, red cat, reduction occurs at the cathode. So this means that this has to be the cathode, okay? Because the cathode increases in mass and the anode decreases in mass, but reduction just always occurs at the cathode. Now it says to you, the impure copper contains zinc impurities which are oxidized to zinc ions. Refer to the relative strengths of oxidizing agents to explain why zinc ions will not influence the quality of the pure copper produced in the cell. So to do this, we can go look at the table over here, okay? And if we go to the table, we can find somewhere here, where would it be? Here is the copper reaction, okay? And here is the zinc reaction, okay? And if you look on the table, there are always arrows. Unfortunately, this table of mine has only got the arrows on the right-hand side. But if you look on your table, on the left-hand side, there are arrows going in the reverse direction, and these say increasing oxidizing ability. That means everything that's on the left-hand side is an oxidizing agent. Everything on this left-hand side is an oxidizing agent. So the one at the top is a stronger oxidizing agent than the one at the bottom, which is the zinc. Okay, so to answer the question, you may only talk about the things that are on the left-hand side of the table. Okay, the left-hand side of the table, because it says refer to the relative strengths of oxidizing agents. So the two things that are on the left-hand side are the Cu2 plus and the zinc 2 plus. So according to the arrows, the copper 2 plus is higher up, so it is a stronger oxidizing agent. Make sure you say the copper 2 plus ion, not the copper metal. The copper is on the right-hand side. It is not the oxidizing agent. The Cu2 plus is the stronger oxidizing agent. And now we must say than the Zn2 plus, because the Zn2 plus is also what's on the left-hand side. And so, because the copper is a stronger oxidizing agent than the zinc 2 plus ions, and so the zinc 2 plus ions will not be reduced to zinc. So basically what's going on here, if we put zinc ions in solution like this, okay, and we have already copper ions in solution, both of them are going to come over here to the cathode, because both of them are positive and this cathode will be negative, the anode will be positive in the electrolytic cell. And so both of these two ions come over to electrode P over here, but when there are electrons being pumped on here, what happens is the copper 2 plus gets the electrons and is reduced, and the zinc 2 plus stays in solution as zinc ions, and therefore we are not getting a mix of copper and zinc there, even though the zinc ions went there. Now it says, what will be observed at electrode Q? Okay, so electrode Q, remember electrode Q is positive, okay? And what is happening here? What do we have in solution? If you look here, it said we started with copper chloride. So copper chloride, when it goes into solution, makes copper 2 plus ions and chloride ions. Okay, 2 chloride ions will come out of this. So because this electrode is positive, my nice little negative chloride ions come to this side. And if I take 2 chloride ions to this side and I remove their electrons, because remember the electrons are being taken to flow through the external circuit, I will form chlorine gas. So at this electrode, chlorine gas will be formed. And then how do we notice this? What do we observe? Bubbles will appear, because that's what we'll see, and our nose will tell us it is chlorine gas. Now it says here electrodes P and Q are replaced by carbon electrodes. We call carbon electrodes inert electrodes because they are non-reactive. So we don't normally put carbon electrodes in a refining situation, because in a refining situation we want the same reaction to occur at both electrodes, but one the reverse and one the forward reaction. Because what are we doing? We're actually trying to put more copper ions in solution from the one electrode. But now if you put carbon electrodes there, no ions will form in solution, and that means all the copper 2 plus ions are still going to go over to this electrode over here, and they're still going to get turned into copper, but they will not be replaced from the anode here. So the carbon anode will not be worn away, and the copper 2 ions will still go out of solution. So the concentration of the electrolyte is going to decrease, because the copper ions are being turned into copper metal at the other electrode, and they are not being replaced at the anode. So the concentration of copper ions will decrease.